let's start the presentation. Hello, everybody. My name is Guillermo Calvino, and I am going to present the system features session with my colleague Vijay. So we have selected these ones that we consider relevant, that are high availability, entity management, system quotas, and system monitoring. And during this presentation, we will show some demos of them. So let's start. Okay, so first we are going to talk about high availability. Okay. First, what is high availability? High availability is about increasing the uptime of a system, so it is able to provide the service without interruptions. Okay, so OSM right now is high available, and this has been achieved thanks to the use of Docker swarms and Kubernetes for its installation, and also the use of redundancy of the OSM components. The use of Kubernetes allows us to maintain the state of the different OSM applications. So if we define that an application must have one pod running and this pod fails, Kubernetes will create a new pod automatically. And additionally, OSM provides redundancy where more than one pod of each application is deployed. So note that all these features have helped a lot to improve OSM's resilience. And this is key for production deployment. Okay, so there are many possibilities when it comes to install OSM. It can be installed in many different ways, and each of it has their own handful options. For this demo, we are going to use the Charm installer. That is a production-ready installer that provides the built-in HA, backups, upgrades capabilities, and the ability of lifecycle management of the installation, being able to scale or configure each OSM element separately. This installer can be used just adding --charm option to the installer script. So the options that we will need to specify to have OSM in high availability are the ones that you can see in the screen. Are --charm to specify that we will use the charm installer, and --HA because we want to make our installation HA. So if we use only these options, OSM will be installed in HA, but just in one node. Well, this could make sense, but for development purposes. In a production environment, it makes sense that OSM uses already existing infrastructure. So for that, we will need to provide the credentials of the clusters we want to use. We have --LXD to tell OSM where the LXD cluster is located, and in the LXD cluster is where the proxy channels will be deployed. The proxy channels will operate the VNF, so they have scripts that will run actions like upgrade or backup or whatever in the VNF. But well, this will be explained more in detail in next sessions. So another thing is --LXD --cred. Those are the credentials of the LXD cluster. --VCA. This one will specify the name of the controller we are going to use, and --case will provide the kubectl file for the credential of the case cluster where the OSM pods will be deployed. Okay, so what are we going to see in the demo? During the demo, we will show how OSM behaves when there is a failure in one of the pods. We will simulate this forcing a deletion of one pod. And another thing, we are going to show one feature called high available proxy charms. So in this feature, we will create a network service with a proxy charm in HA. And well, as I mentioned before, the proxy charm will be in charge of operating the network service. So it can handle the lifecycle management of the VNFs. Okay, so let's move to the demo. Okay, first thing I want to show here in the demo is the command I used to install my OSM. I don't want to do it again. So here you can see that we have used the underlying infrastructure. So we have specified the VCA, the case controller, and the Elxsi cluster that we are going to use for the installation, because we wanted to simulate an installation in a production environment. Okay, so now we are going to review the installation. First, we are going to check the status of the OSM elements in the case cluster. We will use status for that. Okay, as you can see, oh, cannot go up. I don't know why, but I cannot go up with my screen. 1 second, please. Okay, here you can see that the status is active, and here you see that we have 3 units of each one. So as you can see, our installation is in HA. So next, we are going to check the pods. So we will use kubectl get pods in namespace OSM. And here you can see that we have 3 pods of each application. And you can also see that they are in different nodes. In our installation, we have just 2 nodes, OSM1 and OSM2. And all of them are in running state. You can also see, but I don't know if he is seen or not. But here you can see that there is an operator pod for each application. This operator is in charge of create, configure, and manage the instances of the applications on behalf of a Kubernetes user. Okay, so now that we have checked the status of the different OSM applications that run in K8s, we are going to check the status of the VCA cluster. For that, we will change to the controller model in Juju. So for that, Juju switch. And now again, Juju status. And as you can see, we have the VCA that is in HA distributed in 3 different virtual machines. Okay, we have already checked the installation, and now we are going to play a little bit with it. First thing we want to show is how pods are recreated if one of them fails. For that, we are going to monitor one application, and we will delete one pod of it. So I want to monitor here. I need to move again to the OSM model. Okay, I'm monitoring the PLA application. Here I will get the pods. And I'm going to delete one of them. Okay. As you can see, it is deleted and it's created a new one. OSM uses a declarative deployment from Kubernetes, where we define the pods that OSM should be running. So when Kubernetes notices that the number of pods are not the right one, it tries to self-heal this deployment automatically. So we will need to wait a little bit until the unit is in active idle state. And when that happens, that will mean that it is up and running. So that could take just a little bit. Okay, but meanwhile, I'm going to explain what we are going to do next. We will show the high available charms. Okay, you can see that it's active idle, so now they are up and running. And now we are going to show the high available proxy charms. Charms are used in OSM to run day 1 and day 2 operations on the network services. So we are going to create a network service where one of the charms is in HA. So if one of them fails, then the other can still operate the VNFs. So we have already uploaded the VNF and network service packages. So we just need to instantiate. This is the command. You will see it in the Hackfest many times. So for this, we need to specify the network service descriptor name. We are going to use this network service descriptor, and also the VMO account. These config files are to set is used to set some parameters used during instantiation time. So while the network service is created, I want to show you this params.yaml. You can see this field, this config unit, that is equal to 2. This means that 2 charms that are high available for the charm that is in BNF member BNF index 1. So here is where we are telling that we are going to use high available proxy charms. So next, we are going to check the status. It's still in building status. So now we can check also the model of the charms. For that, we will need to switch to that model. That is the ID of the network service. And now we can also watch the status. Okay, as you can see, it's still not as active yet. So we need to wait a little bit while the charms are deployed and configured. Okay, they are all ready. The one that has an asterisk here, this one, is the one that is the leader. So the actions will be run by this proxy charm. So now what we are going to do, we are going to remove the leader. For that, we will use also remove machine, and the machine we want to remove is the 0. Task force. So we need to wait until the secondary, that is this one, becomes the leader. So that could take also a little bit. And when that happens, we will execute an action to check that the charm is working properly. With this action, we will just create a new file in the VM in BNF1. So that's what we want to do. Okay, it's already the leader, so we can execute the action. Okay, let's see the status of the action. As you can see here, you saw a message that was touched. That was the action that was executed. So probably okay, the action is completed. We can double check it. With this command, OSM BNF list, we can get the IP address of BNF1. So it's this one. So if we SSH that machine, we can see that we have created a second file. That is my second unit. That was the one that was specified in the command. Let me paste the command again so you can see it. Here, home Ubuntu, my second unit. Okay, so this is the first demo. So now let's move again to the presentation. Now we are going to talk about identity management and system quotas. So let's start with identity management. An identity management system provides access only to the resources needed to the right people, but only for those. So OSM uses RBAC, role-based access control, for this purpose. And currently, OSM has two different backends. It has one internal that handles identity and assessment resources locally by the NBI, the northbound interface of OSM, and also has an external component that is Keystone that could handle identity management, and that also allow us more advanced use cases. So for identity management system, for OSM identity management system, we need to define roles, projects, and users. Roles are the permissions provided by the identity manager. The authorization is granted if a user has the necessary role to perform an action. There are some roles that are already predefined in OSM, like system admin that allows all possible operations, and also new roles can be created. Okay, so projects. Let's talk about projects now. Projects are organizational units. They provide isolations, so a user that don't belong to a specific project won't be able or do anything on that project. And finally, we have users. Well, the user needs a project and a role in that project in order to be able to operate in OSM. So in order to obtain privileges to do something in OSM, you should have a user belonging to a project with a specific role or roles over that project. Okay. Okay. And now system quotas. This feature was born to limit the resources that a project could use. So quotas are set per project, not per user. They can be applied to all items managed by project. And this is almost everything, as you can see here in the screen, with the exception of user projects and roles. In case of a quote is not specified, there's a default large quota that I think it was 500, if I remember it properly. And well, during the demo, what we will do, we will create a new user and a new project with quotas set. And then we will map the user to the project, and we will see that the quotas applied don't allow us to use more resources than the ones we specified in the project. So now let's move to the demo. Okay. Okay, this is the OSM user interface. Let's log in. And now what we are going to do first, we are going here to the admin part of the panel, and we are going to create a new user. We are already here in the menu. I think that this maybe is quite small. So here in create user, we will create the user that will be quota user. We will set a password and confirm the password, and we will create it. Okay, and now that we have the user, let's create the project. So we are going to create a new project called quota project. And you can see here that we have this quota limit that can be set. If we click here, now we are allowed to set the quotas for this project. We're going to set a quota of 2 BNF packages, for instance, a quota of 1 nego service, and for the rest, we'll leave it in 10, the limit.
What does a quota of 0 mean?
Well, quota of 0 means exactly that. It's you are not allowed to set anything. So if you leave it as 0, that's what you will specify. So you need to set a value here.
Okay, so 0 is not unlimited. 0 means none.
No. Yeah. Yeah, that's good to know. Okay, let's create it. Okay, now we have the project and the user. And next thing we have to do, we need to map the user with a project and with a role. So we have here our quota user, and here on the right, in action, we have projects and roles. So now we can add mappings. So we're going to add our quota project, and we want to be system admin, for instance. And we also can add this to this user more than one project. So now we are going to add admin project, and we are going to be also system admin. Okay, so now that our user has a project and a role, we can log out. We can log in with our passwords. Okay, you can see here that we have been logging in the project Quota project. So if we go here to instances or to packages, we can see that it's empty. We don't have any package. So now we are going to upload some VNF packages. You can just drag and drop. The first one has been uploaded successfully. Let's try with the second one. Okay, it's also successful. And now let's see the third one. Okay, we have exceeded our quota, so we are not allowed to upload any other package. So this is how quota works. Another thing I want to show here, we can change to our admin project. As you can see here, we didn't have any VNF packages before. We don't have any network service package in the Quota project. We don't have any instance. But if we change to our admin project, we need to type our password again. Now we have the instance that we already deployed in our previous demo. So as you can see, the projects, one thing that they do, they provide isolation. Okay, so I think this is all on my side. Now I'm going to leave you with Vijay, with my colleague Vijay, that we will explain OSM System Monitoring. So Vijay, it's all yours. Thank you very much.
Thanks, Guillermo. I don't have the presenter capabilities, so yeah.
So there you go, Jay. You got. Sorry about that. Controls are a little bit different. Took me a moment. You able to share now? There we go. Okay. We see your screen. Thank you.
Okay. Do the participants have access to Grafana dashboard? Mark, can you answer that?
They will once we actually install or set up their OSM instance, which will be happening in about 2 hours. So for right now, they're other than the instructor dashboards, none have been set up.
Sure. Okay. Thank you. Thank you, Mark.
You're welcome.
Hello everyone, I'm Vijay. I'm from Tata. So I have been active in this community from past 2 years with this wonderful community. So I will be walking you through system monitoring of OSM. So to install OSM on Kubernetes with monitoring feature, so you have to follow this installation steps which has been given in this link. And yeah, so here you have to download the installer. So once you download the installer, so you have to run that installer with option C K8S and --K8S monitor option. So once you do install with these options, so you will see OSM components being installed on Kubernetes along with the monitoring components. So it takes some time. So depending on your bandwidth, so to pull Docker images and to install Kubernetes and to bring up monitoring components. So it will take some time, and it will so it's better to have stored your logs into some file so that you can analyze after the installation. So once you install all these components, then you can verify it using kubectl get all and OSM, where you can see all the components running in OSM namespace, and similarly monitoring namespace also. Okay, so how to verify the installation? So that was from the command line front. So this is the UI front. You have to get into the OSM host IP and 3000 port. Then you can see Grafana dashboard popping up. And if you want to log into Grafana dashboard, so you can use by default the admin. The password would be admin and admin. So once you log into Grafana dashboard, you can see the dashboards being organized into different folders. Kubernetes cluster, where you can see the dashboards related to Kubernetes and open source MANO, the dashboards related to OSM, OSM's components such as Kafka, Mongo, MySQL, and OSM components status. And you have in general folder, you will have OSM project status, which is automated, and it will be managed by OSM monitoring module. Okay, so once you install with --K8S monitor option, what are the components that will be installed? So you will have a Linux host. On top of it, you will install Kubernetes. I mean, the installer script will install Kubernetes. And on top of Kubernetes, your OSM components will be installed, and as which will be running as Docker containers. So in monitoring namespace, you will see Prometheus operator, node exporter, and application specific exporters, where we will be using Kafka, Mongo, MySQL exporters to get those the application specific metrics. And we are finally using Grafana visualization tool, where we can visualize the metrics which has been collected by these exporters. Okay, so monitoring option, the option which I said --K8S _ monitor option. So this works only with the K8S deployment of OSM. You have to specify option C K8S for K8S monitoring to work. And so monitoring is achieved. So all the monitoring components will be installed in monitoring namespace. And in monitoring namespace, you will see Prometheus operator, node exporter. So Prometheus is a time series database which stores your metrics, and node exporter to get your Linux host metrics. Kafka, MongoDB, MySQL exporters. These are application specific exporters, which will give you the metrics related to this respective applications. And Grafana for visualization. So where you can create dashboards of your own to visualize the data which has been scraped by these exporters. So how do we install these Prometheus operator? So Prometheus operator and exporters are deployed using Helm charts in the monitoring namespace. The installation of all these will be taken care by that installer. So once you follow the installation guide in OSM page, so you can see you have to run that installer script, and that installer script will do everything for you. Okay, so have captured some snapshots from Grafana. So these are host specific metrics, and these are OSM specific metrics. This is MongoDB metrics, and this is Kafka metrics. And so I will walk you through a live demo of this. Okay, so we shall have a deep dive into monitoring components. So in the monitoring namespace, as I said, you will see Prometheus operator. So this is the time series database, which stores all your metrics. And yes, node exporter. So node exporter is from Prometheus, which will get you the node metrics in Prometheus format, and it will be sent to Prometheus operator to store those metrics. And we have kube state metrics, which will get you Kubernetes specific metrics, and it will be again stored into Prometheus operator TSDB. And we have application specific metrics, which will get metrics from you from the OSM namespace. All these will be deployed in monitoring namespace. And finally, we have alert manager. So if you want to alert a user based on some metrics, so you can use alert manager. So all these alert manager Prometheus operators will have some pre-configured configurations. But if you want to customize, you can customize as per your need. And all these metrics will be piped, which is stored in Prometheus, will be piped to Grafana. Grafana also uses KiwiGrid sidecar container. So sidecar container will get the data from config maps, and it will persist the dashboards for you. If you want to customize your dashboards, or if you want to add your own dashboards on the go, then you have to design your dashboard and get the JSON data, and you have to load config map so that KiwiGrid sidecar will show the dashboard for you. So yeah, it's time for hands-on. So we will see what we can do. Okay. So here I am in OSM mission. So I will be verifying whether OSM components are running or not. Yeah. So here I can see all the OSM components are running, and in monitoring, yeah, I can see all the monitoring components are up. So I have Prometheus and node exporter, kube state metrics. I have MongoDB exporter. I have alert manager. So and I have Prometheus TSDB. Is my screen visible? So I was.
Yes, it is.
Okay, thank you, Mark. So if you want to see all the components, so you can do get all, and you can specify the namespace. Yeah, I have all my components up and running, so I don't have any issues with my OSM components. And we shall check with monitoring. Yeah, so yeah, everything is up and running. So once I verified my installation, so I will move to the UI part, and default password was admin and admin. Yeah, so this will ask you to change the default password. So if you want, you can, but I will skip as of now. Yes, yeah. So I will navigate to dashboards part, and dashboards have been organized into folders. So Kubernetes folder contains the dashboards related to Kubernetes components. Suppose, yeah, so I have core DNS, and I have API server. So similarly, for all the components, a dashboard will be pre-configured to you. And this is related to OSM. I can see Kafka. So message stored per topic, consumed per minute. So these are the Kafka related metrics. Similarly, we have dashboards for Mongo and MySQL also. Yeah, so this will give you overview of how OSM is and what is the status of your OSM components. So the dashboard name is OSM status summary. So we will have some. Okay, so suppose I have to modify this dashboard. So I will take one of the components down, say NBI. So kubectls. Yeah. So you can use this command kubectl scale -n OSM deployment NBI replica 0. So this should reflect in your dashboard. Yes, that was good. Yeah. So I can see NBI to 0. Suppose I want some appealing message. So if the replicas goes down to 0, so I want an error message, or I want error instead of 0. So how can I do that? So I will navigate to visualization, and so I don't want this gauge to be shown. I will disable that. And so here I have value mapping, and I want null to be mapped to 0, or I will map null to error, and I will map 0 to error, and 1 to up. Oh, sorry, it's error. Okay. And I have mapped null to error and 0 to error and 1 to up. So what I'll do is, okay, so the dashboard is changed, but I have to save this. So if you go back, so the changes which you have made will be discarded. So I have to change this. So, or I have to make this persistent. So I will save this dashboard, and so this will give you out the dashboard configuration in JSON file. So I will copy this JSON to clipboard, and I will navigate to this particular directory, and where you will see all your dashboard configurations config map. So as I said, so it was from OSM summary dashboard. So this will be stored here, and so have the data of the dashboard here. So I will, so I need, okay, so I need yes, I have copied the data into clipboard, and I will just paste those data here. And I will indent. So I have copied my changed dashboard configuration here, and I will apply my changes. Yes. Okay. So the another method would be you can save your JSON file here. Yes, save. It will be stored. Okay, my status. And you can upload that downloaded file here to home. Okay. Yes. Yeah, here is the JSON file. And yes, I will have the data. So similarly, I can I have to copy this. So this is a Kubernetes configuration. So where I will tell my Kubernetes to create a config map containing the configuration of OSM summary dashboard. So I will edit this dashboard here. Again, I will indent this. Okay. So I have changed this configuration here, and if I even discard the changes, I should see the dashboard being modified. I will just go back, and if I reload, yes, the changes which I made, so it's reflecting here. So if I scale NVI back to 1, okay, NVI is running. Yes, yeah, here is yes, it is up. So what made this changes? So I have changed value mapping here. I have mapped 1 to up, and I have disabled the gauge. Yes, I have disabled the gauge, so, or else it would have been shown like, so we could see a gauge with the number of replicas like this. So what made this change to persist is because of this annotation, KTest sidecar target. So this annotation will tell the KiwiGrid sidecar container so any config map having that annotation will tell KiwiGrid sidecar container to maintain the state across all the replicas. So that's why any changes you make to a dashboard will stay persistent. So here is what I did. So I went to visualization and I edited the dashboard configuration. I disabled, I deactivated show and activated value, and modified the value mappings, null to error, 0 to error, and 1 to up. And yeah, so, and I got the JSON. So firstly, I copied the JSON data into a clipboard and copied to summary dashboard. And yes, and I applied the configuration. So this is what I did. So do you have any questions?